In this video, I want to introduce the concept of function stubs. So a stub typically is useful when a team of programmers are working in parallel and each team has some responsibilities. For example, one team may be required to create a user-defined function that processes some data from experiments, and this team may not have their function available for several days, and your team is required to write a program to analyze the experimental data. However, since the experimental data is not available because the user-defined function is not available, there's no reason for you to wait several days until it becomes available. You could use what's called a function stub. In other words, you're going to write a function that creates some simulated data so you can complete your program. And in a few days, when the user-defined function is available with the real experimental data, you just have to edit your program to the function name, and it just plugs right in, and then you could run your program, call the function, and it'll be on the search path as discussed in the previous video, and it'll run effortlessly. So how do we create a function stub? Well, in this case, I have an example here that you need to simulate data for 2 experiments, and each experiment is going to have 20 runs or 20 rows of data and representing 40 parts of columns of data. So let's create a local function in the program, and we're going to have 2 data sets output arguments. So I'll call them uppercase A and B, and the function name is data stub. And we're going to simulate experiment data. So this is a good example where we could use random numbers. So A would be a random function. Size, I'm going to say 20 rows by 40 columns. B would be the same. 20 by 40. So we have a proper function, right? We call the function, it's creating data. We're not passing any input arguments, so every time we call the data stub, it's going to return 2 random matrices A and B with random values with 20 rows and 40 columns. So that'll allow us to develop our program. Let's call the function x1, x2, and what am I calling? Data stub. I don't need to see the data. I'll terminate with a semicolon. So the requirements of our program is we need to find the maximum value the max x1 is going to be max simply x1. Max x2 will be calling the built-in MATLAB max function x2. And let's go ahead and create a bar chart. Let's do a line chart. Max x1. Hold on. H2 would be plot max x2. So what's going to happen? I'll put a comment here. Call data stub for simulated data. I calculate the max, and as you recall, the MATLAB functions are column wise, so it'll have the max value of each column for the 20 runs, and we'll make a plot. Run our program. And sure enough, we have our random data, 40 values for each data set, showing the max values. So now, your task is done. Whenever the So when the user-defined function becomes available, you just have to delete the data stub call and call the user-defined function. And remember, when you call a function, you could define whatever the return variables are, and the rest of your code, x1, x2, remains unchanged. So if you had a more complicated program, maybe you need to call functions, so we could pass in values x1, x2 to do some more sophisticated analysis. And you could modularize your program by creating more functions. But now using this stub, you just have to replace the data call function, right? When a function becomes available, replace it with the appropriate function name, and you're off. So that's a data stub, and it's most useful, as I mentioned, is when teams are developing parallel processing, develop code in an expedient and efficient fashion. It's kind of hard pressed for a single user to make stubs, but it could very well if you're focusing on the algorithm for the analysis part. And then at the final stages, you go ahead and create your user-defined function. Maybe the experimental data is not available yet. So in that case, the stub becomes useful. Thank you.